In this video, we are going to review normal distribution. So the first thing that we need to know is how to compute z-scores and also how to interpret them. So the z-scores convert everything to the same scale, and it would not matter what the population mean and population standard deviation were. We are able to compare using just the standardized with the z-scores. All right, so here is how we compute them. So let's open the Desmos graphing calculator. And the first thing we do is when we use this formula, we're going to use division. So let's go ahead and click on division so that we have a numerator and the denominator. In the numerator, always remember to start with the number that you are trying to standardize. So this baby weighs 3,560 grams. So I'm going to put that there and then subtract the mean. Okay, so the mean is 3,500. And then on the bottom, you want the standard deviation, which is 541. Okay, so once I got that, I need to round it to 2 decimal places. So let's go ahead and do that. So that's 0.11. And the z-score tells you how many standard deviations this person, this individual, is to the right or to the left of the mean. So if the z-score is positive, then the value is larger than the mean. And you can also tell by that 3,560 is larger than 3,500. So you already know that this is going to be above. And you can also see that the z-score is positive. So what that tells you is that the baby who weighed 3,560 grams is 0.11 standard deviations above the mean. Okay, now, so these values would be the same if the z-score is positive, because we are taking absolute value when we interpret. An absolute value of 0.11 is the same, 0.11. Now let's redo the same thing for a baby who weighed 2,270 grams. So all I have to do is just change this number to 2,270, and of course I would need to round again. So that is now negative. So this is now negative 2.27. Now what that means is that this baby is below the mean, right? And we can also tell that the weight of the baby 2,270 is definitely less than 3,500. So that means it's below. Now in here though, you are not going to put negative 2.27. You need to put the absolute value, meaning that you're going to disregard the sign. And that means that this baby is 2.27 standard deviations below the mean. So in the interpretation, you do not use negative values, but the value itself, you absolutely should keep the minus. Okay, now let's go ahead and review how to compute normal probabilities and percentiles. So let me close out of these two, and let's go to the plus sign. Let's go to inference. Under inference, we are going to select probability distribution. And this time we are dealing with normal distribution. So we are going to enter the mean, that's 3,500, and standard deviation 541. Okay, so click on create distribution. And that'll allow us to also visualize the situation. Okay, so let's go ahead and expand the cumulative probability. And the first question says, what is the chance that the baby weighs less than a certain number? So if it's a less than, we're using the region left, and then we just put 2,885 in the blank, and so that value is 0.128. Also visually confirm that the area shaded is the area to the left of your number. The next question says, what is the probability that the baby weighs more than 3,226 grams? So for more than, we use the right under region. So let's delete this number, put whatever number we got, that's 0.694. Okay, so that's the probabilities, but now we want to discuss the percentiles. To find the percentile, what you need to do, first of all, remember that all percentiles would be associated with the left region. So region would be left, but the percentile is the bound so that the area to the left of it is equal to the given percent. So you need to find the bounds now. So under compute, you're going to switch to bounds. And again, region is left. And then you're going to put whatever percent, you're going to put that in here, but you cannot put 25. You have to convert the percent to a decimal by dividing by 100. So the 25 divided by 100, that's 0.25. okay? And then that corresponding number would go in the blank right here.